We're now going to solve a problem involving electricity here. And if you're thinking, oh man, I don't know anything about electricity, you probably know about as much as I do. But we should still be able to solve it because we're going to be given the equation here that relates voltage to I and R. And I is the current, R is the resistance. So the current is given in amps, the resistance is given in ohms. And we're told that the voltage is increasing at the rate of 1 volt per second, while the current is decreasing at a rate of 1/3 amp per second. And so then it wants us to find the rate at which the resistance is changing when the voltage is 12 volts and the current is 2 amps. Okay? And then it wants to know, is R increasing or decreasing? Is the resistance increasing or decreasing at this point? So let's see if we can put this all together here. So we have V, I, and R. We actually have 3 variables here. And in here it gives us some information. It actually tells us dV, dt. The voltage is increasing at a rate of 1 volt per second. So this is like 1 volt per second. And then I'm told that the current, I, is actually decreasing at a rate of 1/3 of an amp per second. So that's actually di dt. And I'm told that it's decreasing, so it's a negative 1/3. And this is amp per second. Okay, and then all of this is when V is 12 volts and I is 2 amps. Okay, so when voltage is, V is 12, I is 2, these 2 rates are given here, and then I'm given this equation that relates them all together. And now what I'm going to do is I'm going to use this idea of related rates to find what it's asking for. And what it's asking for is it wants us to find dr dt. Okay, that's what it wants us to find when V is 12 and I is 2. Okay, so what I'm going to do is I'm going to take the derivative with respect to t of both sides of this equation. Okay, so d dt of V, d dt of I times R. Okay, well this is easy. The derivative of V with respect to t is just dV dt. Now what about this side? In this case, you really have, both of these are implicit functions of t. So this is like I of t times R of t, right? So it's the product of 2 functions. And these are implicit functions of t. And so I'm going to have to use the product rule. So I'm going to take the derivative of the first one, which is di dt, times the second one, which is just R, plus the first function times the derivative of the second one, dr dt. And so I'm given this equation here. So what I want to do is I want to find dr dt. So I want to find this, okay, and I'm given dv dt, I'm given di dt, I'm given r and I, I'm given everything else. So I'm going to solve this for dr dt. Okay, so if I do that, I'm going to have basically dv dt, and I'm moving this to the other side, minus di dt times r, and then I have this on this side, and then I need to divide to get dr dt by itself. I need to divide by I. So I'm going to divide all this by I, and that's going to be my dr dt. So what I've done is I've solved, I moved that to the other side, divided by I, and so basically I'm given all this information, and I need to put it in and calculate what my dr dt is. So maybe I'll do this over here. dv dt is 1, minus di dt is negative 1/3, times r, let's see, I'm given that the resistance is changing. Oh, you know what? This is an interesting example because I need R here, but I'm not given R, but I'm given the equation that relates all these together. So I actually have to find R. So basically I'm going to plug in V and I into here. So V is equal to, and then I is 2 times R, and so my R is equal to 6. So I could add that here. R is equal to 6 at this time, right? And that's what I put in here. So this will be 6, right? And then I need to put in my I, and so my I is 2. It would be like that. Okay, so now this is going to be 6 times this is going to be minus 2, but 1 minus a negative 2 is 1 plus 2, so that's going to be 3 on top, and that's going to be 2 on bottom. So it will look like that, 3, 2, and resistance is ohms, so this is going to be ohms, ohms per second is what it would be. And so that's the answer. What is the resistance? It's actually, is it increasing or decreasing? It's actually increasing by 3/2 ohms per second. Okay? So again, we didn't have to really know what current and ohms and voltage, exactly what all those mean. We just needed this equation that relates those three things together, and we need to be able to read this part of the problem and find out what it's telling us, and it's giving us rates of change at different times. And in this example, I didn't realize it until I got to that point, but this example, I was given this in the problem, but in order to find out the rate, I had to plug in R. And that wasn't a problem because I was given 2 of the 3 here, and I could solve for R and then plug it in and get the rate that it was asking for. So that's a nice example here, in this case involving electricity. So we'll look at some more examples here.